So this is homework one. I don't even know what this is. Homework one, part C. Questions. Okay. Let's start over now. This is homework one, part C, questions 3 and 4. We've already answered 1 and 2, which is just deriving an expression for force using Cartesian and polar parameterizations. So now we're going to use Python to numerically integrate and compare results from Cartesian and polar parameterizations. So we're going to start, of course, with import SMP, NP. We also want to import SciPy as SP, and we're going to start by defining the integrand. So let's put it here, define integrand of z, h, and r, and then it's going to return, we want to return h minus r plus z, and it's going to be times the square root of r squared minus z squared. And then we're going to specify some constants. So we'll have r, which is 1 meter. We will have h, which is 1.5. We'll have rho, which is equivalent to 1,000 kilograms per meters cubed. And then we will have g, which is 9.81 meters per second squared. And now we'll do the SciPy integrate.quad as we were told to. So if we do sp integrate.quad of our integrand r minus h, we have regular r, that r equals hr, close that out, equals 0. But we need to add but we do need to add 2 times rho times g. So we'll have 2 times rho times g, and then it'll be times this entire thing here, and then should get a value of second. I fixed it, just accidentally mistyped square root. So that is what we get for that. And now if we want to plot it, we're actually going to start by going back up here, and we want to do, goodness gracious, just kidding. So that is our Cartesian parameterization. Now we're going to do it for polar. So we're going to define integrand, I'm going to call it just integrand 2, in terms of theta and theta naught. So we're going to return NP sine of theta naught minus NP sine of regular theta, and that's going to be times NP cosine of theta squared and then we're going to have theta naught, which will be equal to arc sine of h minus r divided by r. And then we will also have that 2 times rho times g times r cubed, and then all of that times, we're going to take something very similar, just do this, it's fine, sp dot integrate dot quad of the integrand 2 so integrand, and then mp pi over 2 theta naught, and then ours equals, put that parentheses, theta naught on the outside 0. Close that up, and then run that. Nope. Just and then that gives us our value for our polar parameterization. So the next, what we are going to do is plot this. So actually, before we do that, we can go back up here, and we're going to add from plotly dot subplots import make subplots, so that way we can actually see what we have plotted. And then we're going to go back down to the bottom here, and we are going to do h values, which are going to be equal to the linspace of 0, r times 2, and 25. And then we're going to have our forces, which will be equal to integrand 2 integrand 2 h and h values. And then to start our plot, we want to do big equals make subplots, and then to establish our x and y axes, fig add scatter, x is going to equal our h values, and y will equal our forces. So if we have that, let's run it. So, Jesus Christ. Alright, we finally have it figured out now. And there is our completed plot.